This week, we're changing topics to, I'm going to go out and say it, this is the most important week of the class. What you learn here is one of the most important tricks of the trade. It's called, I'm going to write it up on the board, the singular decomposition. Let me make this a little more pointy. So one way to think about this process is that what you actually did is you took this, you rotated it, and then you stretched it. Let me draw sort of a ball of the same radius here as this here, and you could see what it did. It rotated by some angle theta to here, and then you stretched it out a little bit. Some combination of rotation and stretching. Okay, so a little bit of this plus a little bit of this, and this plus a little bit of this plus a little bit of this plus this plus a little bit of this. Well, the 2,6 is just twice as long. That's it. So you can see that this thing will just stretch. If alpha is bigger than 1, it stretches it. If alpha is less than 1, it compresses it. If alpha is 0, it makes it 0, of length 0. So think about this as a ball in 2 dimensions. In 3 dimensions, it's a sphere. In 4 dimensions, or 5 or 6 or more, they're called hyperballs. And I ask, what does it do to a computer? What it does to a computer is it rotates, and then it either stretches or compresses it. That's it. Okay? That's what the matrix A does to an individual computer. Okay? That's what the matrix A does. There is the major computer and the minor computer. So I can think about, there's my major computer, there's my minor computer. Actually, okay, major and minor. And what I can do is think, oh, those are a new coordinate system for me. So I started off with the coordinate system over here, orthogonal directions. So there you go. I took a coordinate, and under the matrix operation, it stretches with some rotation into a new set of x. All you did is you took a coordinate or took a set of x, you rotated them, you stretched them. That's it. Okay? So that's one way to think about it. And again, here it is. Here's the main idea. Take a coordinate. When you multiply this thing, you rotate, you stretch. Okay? That's what you're thinking about doing. And let's not just take a single coordinate, but a whole, set of basis x for this system into what happens in this new stretch system, and this is it. Okay?